Good morning, students. In last period we seen the exercise 1.5. Now we completed the chapter mathematical logics. Last point of the chapter is problem set. In problem set there are 17 problems, but I select only 5 problems because 12 problems are solved in previous exercise. So that's why I does not repeated that problem. फक्त 5 प्रॉब्लेम घेतलेले आहेत की ते वेगळ्या पद्धतीने दिलेले आहेत. बाकी 12 प्रॉब्लेम हे आपण अगोदर सोडवलेल्या एक्सरसाइजवरच आधारित आहेत. फर्स्ट प्रॉब्लेम इन द गिवन प्रॉब्लेम सेट इज डिटरमाइन द ट्रूथ व्हॅल्यूज ऑफ P and Q in the following cases. Here problem is given as P or Q is true and P and Q is true. Since P or Q, we know that the truth table of the P or Q, if both the statements are false, then final statement is false. That means P or Q is true. It follows that both P and Q have truth values T, or one of them is true and other is false. Second case, P and Q is true. We know that P and Q is true if and only both P and Q are true. It is only false if both the statements are P and Q are true, otherwise it is false. Therefore, P and Q is true if and only both P and Q are true. From A and B, we conclude that P and Q has truth value T. Second problem is P and Q is given F and P and Q implies Q is T. Here P and Q is false if both are false or one of them is true and other is false. Second, P and Q implies Q. We know that in one way implication T of F means given statement is true, then T of F means first statement is true, second is false, then false, otherwise true. But here given that it is true if and only P and Q is true. Therefore from A and B we conclude that P and Q has truth value T. We have to find the truth values of P and Q. Second problem is not in new syllabus, it is in previous, but problem is new and it is good one. Therefore I will take that. Consider the following statement. We have to given 4 statement, 5 statement, 5 statement or 6 statement, and we have to show that which have same meaning. That's why I take the example. If a person is social, then he is happy. First statement given that. If a person is not social, then he is not happy. If a person is unhappy, then he is not social. If a person is happy, then he is social. That 4 statement patterns are given. We have identified the pair of statements have same meaning. आपल्याला काय पाहायचं आहे की याच्यापैकी कोणत्या याचा 4 स्टेटमेंटचा अर्थ सारखा आहे की 2चा सारखा आहे की कोणत्या 3चा सारखा आहे. म्हणजेच आपल्याला चेक करायचे आयडेंटिफाय द पेअर ऑफ स्टेटमेंट हॅव सेम मिनिंग. दॅट्स वाय आय यूज फॉर दॅट देर आर लॉट ऑफ मेथड्स. इफ यू know the rules, then we can identify it, but if you have no rules, then you must prove by using truth table. I identify first PQ, negations P and negations Q. What is meant by P? A person is social. Negation P is a person is not a social. Q, a person is happy. Negations Q, he is not happy. Symbolic form of the given truth table is I defined as PQ, negations P and negations Q. Therefore, if a person is social, then he is happy. P implies Q. If a person is not social, then he is not happy. Negations P implies negations Q. A person is unhappy. Unhappy means not happy. Then he is not social. Negations Q implies negations P. If a person is happy, then he is social. Q implies P. I take all the statement pattern and draw the truth table. When we draw the truth table, we know that P for T, T, F, F, Q, T, F, T, F, negations P, T, T च्या ऐवजी आपण काय घेऊ शकतो F, F. Therefore F, F, T, T, F, T, F, T. P implies Q. We know that in P implies Q, T, F, F. Therefore F, otherwise true. Negation Q implies negations Q. Negations Q, P implies negations Q, T, F, F. Otherwise true. Q implies P. Q implies P is T, F, F, T, F, F, otherwise true, and negations Q implies negations P, T, F, T, T. We know that when we observe the all columns, then we know that we get column number 5 and column number 8 have identical truth values TFTT and TFTT. That means 5 and 8 have same meaning and 6 and 7 have same meaning. Therefore, what is the 5 and 8? 5 means P implies Q is logically equivalent to negations Q implies negations P, and Q implies P is logically equivalent to negations P implies negations Q. That means statement A and C have same meanings, means if a person is social then he is happy, and if a person is unhappy then he is not social. It has same meaning. And if a person is not social then he is not happy, and if a person is happy then he is a social, have same meaning. It is the answer of the given example. Next problem is simplify the following circuit so that the new circuit has minimum number of switches. Also draw the simplified circuits. Means या डायग्रामचा ऑब्झर्व करायचा आणि ऑब्झर्व केल्यानंतर याच्यावरून आपल्याला याच्यामध्ये 6 स्विचेस आहेत. आपल्याला असं सिम्प्लिफाईड सर्किट तयार करायचं आहे की ज्याच्यामध्ये मिनिमम स्विचेस राहतील. मग कदाचित 2 असू शकते, 3 असू शकतात. मग आपण काय केलं, त्याचे लेट पी क्यू आर निगेशन्स पी निगेशन्स क्यू डिनोट द स्विचेस S1 S2 S1 dash S2 dash आर क्लोज. L द लॅम्प विल ब्लोज. द लॉजिकल एक्सप्रेशन ऑफ गिवन सर्किट. लॉजिकल एक्सप्रेशन काय होईल याच्यामध्ये, P अँड निगेशन्स Q, P and negations Q, or negations P and Q, negations P and Q, or negations P and negations Q, negations P and negations Q is logically equivalent to L. Now we write P and negations Q and negations P and negations Q, that first and third in one bracket and second in next bracket. That means we use the property only. This is called associative law. It's called associative law. Now P and negations Q or negations P and Q. Here negations Q is common. Therefore we use the distributive property and common out negations Q and write P or negations P and negations Q. Last bracket is as it is. P or negation P is nothing but it is a T. It is a complement law. It is a complement law. T and negations Q is negations Q. It is identity law. All second bracket is as same. Therefore negations Q or negations P and Q. Then again we use the distributive law. Negations Q or negations P and negations Q or negations Q. But negations Q or negations Q equal to T is also complement law. Therefore negations Q or negations P and T. Therefore negations Q or negations P equal to, we use the identity law, and therefore negations P or negations Q means we interchange, that is called commutative law. We use the commutative law. Means at last we start from here and end here. Therefore we get the simplified form of the circuit is in the form of negations P or negations Q. So we draw the simplified circuit as negations P means S1 dash. Here connection is or means parallel connections, S2 dash. Therefore we draw the simplified. Therefore we, by using all this rule, we find the simplified form of the given circuit, and the simplified circuit is, we get the answer negations P or negations Q. Therefore the simplified form is S1 dash means negations P, S2 dash negations Q. It is in parallel connection because R is parallel connections. It is a diagram of simplified form. Simplified form. Simplified form. Question number 4 is check whether the following switching circuits are logically equivalent. Here 2 examples. In 2 examples each have 2 examples. Both are logically equivalent. We have to check. These 2 are logically equivalent. We have to check. First, we observe the circuits, give the names PQRS and S1, S2, S3 are closed. We give the switches and write the symbolic form of given circuit is first is P and Q or R, second is P and Q or P and R. We distributive law use here P and Q or R. P and Q or R is logically equivalent to P and Q or P and R. Therefore, LHS equal to RHS means LHS equal to RHS. Therefore, the given circuits are logically equivalent. That 2 circuits are logically equivalent. Now, next example, similar of that example, we write first PQRS denotes S1, S2, S3. Then we write the symbolic form of the given. The first symbolic form is P or Q, P or Q, and Q or R, Q or R. Second one, P or Q and R, P or Q and R. Therefore, if we take first or second, P or Q and R, P or Q and R, we use the distributive law, P or Q and P or R. But this P or Q and P or R and P or Q and Q or R are not identical. Therefore, the both circuits, first and seconds, are not logically equivalent. Are not logically equivalent. In example 5, here give the alternative arrangement of the given circuit so that the given circuit has 3 switches only. Here near about 12 switches, but we have to find the new circuit, which is called as a equivalent circuits, have only 3 switches. Now we give the numbers PQR, denotes S1, S2, S3, L be the lamp. The symbolic form of the given circuit is as P and Q and negations P, P and Q and negations P, or negations P and Q and R, negations P and Q and R, or P and Q and R, or P and negations Q and R is logically equivalent to L. Now we arrange these circuits in such a way that P and negations Q, P and negations P in one bracket and Q. Then we common out R here, R. Negations P and Q, or P and Q, or P and negations Q and R. Now P and negations P is F. We know that the complement law. Therefore F and Q is F. F or the same bracket is as it is. Now F or Q equal to Q. Therefore by identity law we get the given bracket as it. Now negations P and Q, or P and Q, or P and negations Q and R. Therefore negations P or P and Q. Now we use the distributive law, or P and negations Q. Here Q same. Therefore we use for 2 bracket distributive law. If we expand by distributive law, we get the previous bracket. Negations P and Q, or P and Q. We use for 2 brackets here distributive law. But negations P or P is T by complement law. T and Q is Q by identity law. So we solve it, and by solving we get Q or P and negations Q and R. Now we use again here distributive law, Q or P and Q or negations Q, Q or P and Q or negations Q and R. Q or negations Q is T. Again complement law, Q or P and T equal to Q or P is identity law. Therefore by identity law and complement law we get Q or P and R, or P or Q and R. This is a simplified circuit which have PQR, means 3 switches. Therefore we draw the simplified circuit diagram is as here. For P we use S1, for Q we use S2, and for R we use S3. Q or P means P and Q. P or Q is in parallel connections and it is with series connection. Therefore we draw the simplified circuit as in the form. Now we see. Now example number 6 or 16 in problem set. Draw the simplified form of the following circuit. The problem is same as previous problem. We first observe the circuit, then write here S1, S2, 2. Therefore P the switch S1 is closed, Q the switch S2 is closed, L the lamp will be closed or blows. Now we write the symbolic form of the given expression is, or given circuit is, negations P or Q, negations P or Q, or P or negations Q, or P or Q, P or Q. Then we rearrange this, which is called as associative law, negations P or Q, or P or negations Q, or P or Q. Then negations P or Q or P or Q, first and third, we write first and third first, then second, means third time. Now we use for negations P or Q or P or Q, the distributive law, negations P or P or Q or negations Q or P. Therefore, here we get negations P or P is T. It is a complement law. T or here also T, and P or P equal to P. It is a idempotent law, and therefore T or P is by identity law we get T. But we know that T is not any circuit. Therefore, since the circuit is not labeled properly, because for T we cannot draw the simplified circuit. To draw the simplified circuit we have to get PQ or any S1 S2, but here we get T, and for truth value we cannot cannot draw the simplified circuit. Therefore, we cannot simplify the given example. In this way we completed the math. In this way we completed in near about 15 grade the mathematical logics and all its exercise and problem sets. Thank you. Good luck.